Thank you, Charles, for the very informative presentation on a variety of projects on how do we use AI for transportation applications. Now, I would like to invite two speakers to join me at the panel. There are two microphones in the front. If you have questions, please come to the front. Use a microphone to ask questions. There's one. Jonathan.
Thank you very much for, it's helpful for me to see what's going on in areas I don't work in, so thanks very much. So my question's for Amy in particular. I was looking at those air quality monitors and how you had such disparate readings that were quite close to one another. And I understand you gave an explanation about buildings and airflow, and it's perfectly plausible. Let me suggest, and maybe you can rule this out, but I was doing some work on similar urban areas and using, I didn't do it, other people did it, doing some mobile monitoring using mobile detection units, and they found that there was like a methane leak. I'm wondering if if you've managed to rule out the fact that it's not vehicles, but you could have other sources of emissions that are causing those sensors to be so high.
Yeah, that's a great question. I can say it's not methane because we can't measure methane, but it could be something else. We definitely had one day, we had somebody on our team flag something and call our technician, hey, I think you need to go check this sensor. And he said, no, actually, I was just there. They're laying new asphalt underneath it, right? And that's only going to happen once. So we get a little bit skeptical when it's consistent. And that's when we start to work with our city partners to understand, is this a place where you see a lot of backed up traffic? Like, what is the other information we can collect to come to a conclusion about what's happening here? The other thing we can do is these sensors actually, I didn't give you a lot of detail since this was a quick talk, they measure 7 different things, and we can start to look at ratios between the different pollutants, and that helps us to assign whether we think it's more likely diesel vehicles, more likely gasoline vehicles, more likely not a transportation related source at all. So that kind of fingerprinting that we can do with the multi-pollutant aspect is helpful.
Thank you.
Hi, I'm Sophia with RBI. And I don't know if Charles was here yesterday. We were talking about Insights, which is a LiDAR like aerial. Is basically we want to create a digital copy of a metro area, which is essentially what you presented on. So we'd love to hear more about like the quantitative accuracy of your AI models, like false positives, false negatives, and then like yeah, I mean, we have a lot of questions, but that's probably the most important one.
Sure, yeah, and happy to connect after. I mean, no model is going to be perfect.
Right.
I think we aren't aiming for perfect. I think our group's aiming for efficiency. Instead of a year and a half and thousands of people hours, if we can get it down to, you know, a couple hundred or a few hundred to train a model and then a few hundred of QC, then we consider that a win. And so you're right. Some of the models are more accurate than others. There's been some where we can get to 90% and some where we can't get anywhere close to that. It depends a little bit on sort of what is the asset that we're trying to extract. So happy to have a further discussion there, but you're 100% right that some of them are, yeah, we definitely still have to do a lot of review in QC, but for us, it's still a win just because we're not just from a cost perspective, but from that perspective around sort of the system of systems. If we're able to get the data to decision makers before it's a year and a half stale, like that's of a lot of value to us.
I guess a quick follow-up is like, what is the end goal in terms of frequency of like getting, do you want a real-time like updated map or is it just for assets, or do you want to use it for traffic control, or yeah?
I mean, all of the above would be great, right?
Yeah.
But we want to build these systems out. I think we're also installing other systems to try to help. So in part, because while we're not 100% required to federally in Massachusetts, we want to have a comprehensive data set for the entire road network, including municipalities and trails and small roads and private roads even. It can be difficult where we can install workflows where when a project goes in, that gets built out. So by building this set, what I'm trying to get at is by building this set, we can sort of continue to keep it updated and then refresh it as needed. It would be great to get it to an annual basis so we could like understand exactly where it is each year when we do our annual sort of frozen release. But there's a lot of barriers to doing that still.
Okay. Yeah, we'll definitely talk.
We should definitely talk 100%.
Hello, can you guys hear me? My name is Alex Cole. I'm with Basalt International. I wanted to ask, because I'm interested in that black box, and so as an engineer, I have a fairly shallow understanding of coding, not comparable to what you guys do, obviously. But I guess my question is, for a company like ours and maybe just other engineering companies, is it feasible for engineers at that kind of level to be able to utilize deep learning and AI, or is that something that needs to be done at a very low level, like using computer language and not simply programs that may be able to run AI?
Amy?
Do you mind if I take this?
Yeah. take it.
I actually would advocate that I think it should be the engineers. I think the more that we know the domain knowledge, the better we do at actually using these tools. So to be honest, calling and training any one of these types of machine learning models in Python or R, any programming language, it's one line of code. That one line of code is not that hard to look up on Google and figure out how you format that one line of code. The most important thing is having the right data, knowing how to format your data, noting what the data mean, what they can do, what they can't do. A computer scientist coming to work with you won't know any of those things. So I think teamwork is great, but I also think that having all of that in one person's brain at the same time can really give a lot of value. So we have several graduate programs at Northeastern that we've built for this reason, for civil and environmental engineering, to give those students data science classes too. So I think it's not unachievable. I think in relatively short order, I think it's totally doable because most engineers are familiar with many other software tools and many other types of models.
Great,
Yeah.
Thank you.
I mean, the only thing I would add, I would 100% agree. The only thing I would add to that, there are even solutions that make it codeless. So if you really don't want to code, but yeah, the subject matter expertise is the most important piece.
Oh yeah, and look up Google Colab. Google Colab makes the coding much easier. So they have like built in, so you don't have to deal with the Python libraries and all that crap. So that's like a very good way to get started.
Yeah.
Google Colab,
Yeah.
just C-O-Lab, yeah.
And I love coding so much, so I wouldn't give coding away. But I will have a piece of advice here is that do the homework by conducting a thorough literature review. The problem that you're trying to solve maybe has been solved or currently being studied by other people, by other groups. And don't try to reinvent the wheel because computer science is not our major. We are civil engineers. So find a shortcut and learn from others.
Thank you for the presentations. Sorry, can everybody hear me? Yeah. I think it's great that we're looking into AI and machine learning and engineering. I think one of the biggest hurdles, at least that I've heard from colleagues, is making decisions based off of the outcomes of that AI. Because at the end of the day, if I'm sending out a report, my name's on it, my stamp is on it. So, how do we kind of bridge that gap to make engineers feel comfortable with the data or the results that are coming out of that black box to where, I can make decisions and tell my clients that they need to do 500 square feet of concrete repair without, just pointing at the AI and saying, because they told me.
I would ask you how you make that decision with any other model. I'm guessing error bars, right?
Not models that we would do with physical inspections if we were doing something like delamination surveys.
But would you inspect every single one?
If we're doing a bridge deck, yes.
So you would probably use an AI tool in that case to make that process faster. The cool thing is that in machine learning, you can get the model to tell you how confident it is. And I think you saw this in some of the models that were up there. So you could say, okay, if the model is over 90% confident, I trust this. If it's under 90% confident, now somebody on my team has to review it, right? And then you just make your job faster, but you maintain that confidence. So I think we as engineers, we have a sense of quantifying our uncertainty that's always carried through everything we do. And you can actually build that into machine learning models, but people never talk about it. So we get this sense that it's just like, it gives you an answer and that's all you get. That's not actually true. You can get uncertainty out of them. And I think we should take more advantage of that, especially in what we do where safety is critical, where dollars are critical, and we have really like public stakeholders and public tax money that we're obligated to be responsible for.
That's great. I feel like a lot of the time it's kind of this can do everything, but knowing that you can get confidence out of it.
Yeah, and I think it's really underutilized, in my opinion. Yeah.
Thank you.
Charles? Everything to add?
I disagree. Yeah. Nailed it.
Any other questions? Okay, if not, let's thank our speakers again.